So little stuff actually. This is so messy, I don't know where to start. It was like, no, it was me having the work.
Sorry, I forgot to bring up my core index so that you open up the email. Okay, for the exercise 14.1, sorry, 15.1 that I've just written to you, I generally don't have much comments. You look at your own piece of work. Okay, I've already uploaded the solutions onto Google Classroom. Okay, so you could check your own answers. Alright, give your exercise 4B, 4C and 4D, right? Okay, any problems with exercise 4B, question 5 and question 6? Any issues? Okay, how about exercise 4C, question 4C and 4D? Any issues with that? Okay, then what about exercise 4D, question 4?
Part 2.
4 part 2. Sorry, let me take a look. 4D, 4 part 2. Okay. Let me just write it down. Okay. Then how about question 5? Question 5, any issues? Is question 4 part 2 just only one person's concern? Or everybody's okay, is it? If it's okay, then maybe Matthew later I come and help you with it. Okay. Question 5, any problems? Question 6. Question 6, okay. Question 6, is it the entire question? Okay. Then let's look at question 6. Okay, let me just connect it on screen. Chromebook plus foolscap paper to library later. I can, Okay. Alright, question 6. So we are given that a hamper company packs 4 different gift hampers Okay, happiness, prosperity, bumper, harvest, and good fortune. Okay, so in each of the different hamper, that it contains different kind of stuff. Okay, the cost price of each of the following item is as shown here. We want to write down two matrices such that the product of the elements, okay, under matrix multiplication will give the cost price of each of the hamper. That will mean that in order to find out the cost, this value of 2 for number of cans need to multiply with $30. Okay, the groundnuts need to multiply with $1.80. And then the box of chocolate need to multiply with $4.80. Box of candy need to multiply with $3.50. And the packet of biscuits need to multiply with $2.40. Followed by adding them up together in order to know what is the cost for happiness, prosperity, and each of the hamper in general. Okay, so the two matrices that we will need, okay, will be following the table 2, 6, 5, 4, 5, 3, 8, 2, 3, 2, 4, 9, 3, 6, 3, 3, 5, 6, 3, 4. Okay, and then each of the number need to multiply with the cost itself. So actually following the table itself will give you the two matrices that we need. Okay, so this will be the two matrices. It's perfectly okay if you want to drop the 0 in the decimal cost. Okay, so you want to put 1.8, 4.8, 4.5, 2.4, that's fine. So multiplying these two matrices together, we will take this number, multiply with this with this, and so on. So this is actually a 4 by 5 matrix, and this is a 5 by 1 matrix. Our end product will be a 4 by 1 matrix. So I leave it to you to do the calculation. Okay. Then the company receives an order for 85 happiness hampers, 90 prosperity, so 85, 90, 80 bumper harvest, and 120 good fortune. Okay, form two matrices so that the elements of the product of these two matrices will give the total cost price of the hampers ordered. So that means that, right, okay, if I have found the individual values over here, okay, for each of the different costs, I need to multiply with 85, prosperity, bumper harvest, and good fortune. Okay, you will realize that with this being a 4 by 1 matrix, and this is also 4 elements, okay, eventually what I want is actually 4 elements as well. Okay, so a 4 by 1 matrix and another 4 by 1 matrix, no matter how we shift it around, it doesn't give us the eventual product that we want, right? Okay, which is actually 4 elements only. So what we could do, with this being 4 by 1, okay, wait up. Okay, so if I want to make use of my answer in part I, which is a 4 by 1 matrix, and knowing that at the end, okay, itself, I need a matrix that will tell us the total cost price of the hampers ordered. Wait, total cost price of the hampers ordered. Oh, okay. So I was thinking of so I need 1 by 4 can. Oh, okay, can. Sorry, I was thinking of something else. Okay, so I can do a 1 by 4. Okay, because eventually I need a 1 by 1 matrix because I'm only looking for the total cost price of the hampers, not the individual cost price. Okay, sorry, I misread that. Okay, so therefore my 1 by 4 matrix will then be 85, 90, 80, and 120, with each multiplying each of the individual costs. Oops. Okay, so that I will actually in the end be able to get a 1 by 1 matrix, right?
Wait, now.
Okay, then after that, part 3. Company intends to make a profit of 30% on each happiness hamper, 25% on each prosperity hamper. Let me just write that down. Plus 30%, plus 25%, plus 20%, and plus 15%. Okay, form two such matrices such that the elements of their product will give the eventual selling price of each of the hampers. Okay, so we're looking for each of the selling price. Okay, so that will mean that so the two matrices that we will form, okay, because we are looking for selling price of each of the hamper, okay, so each of the hamper is going to have an increment of 30% from the cost price itself. So in our part I, we actually have the cost price of each hamper, okay, whereby we have the happiness one, the prosperity, the bumper harvest, as well as the good fortune, right? Okay, so in order for us to determine, okay, what is the selling price of each of the hamper, we eventually want 4 elements itself. One for happiness, one for prosperity, the other one for BH, and then for GF itself. Okay, so that means that the values that we got in part I need to multiply with 1.3, okay, for happiness, 1.25 for prosperity, and so on. Why is it 1.3? Because we're adding 30%. Original is 100%, that is 1 whole, 30% is 0.3 in decimal. So therefore it's 1.3. Okay? So why is it that I use such a structure for my matrix rather than a 4 by 1 or 1 by 4 matrix itself? Because I keep in mind that I want a matrix with 4 elements. Okay? So I originally have a 4 by 1 matrix, and that is only possible if I make use of the identity structure. If you remember your identity matrix, okay, that structure itself whereby the diagonals are all the numbers and then the rest are zeros. Because what I want in my first element is just by 1.3 multiplying with the happiness cost, okay, the rest I do not need. So I times 0 for the rest. That's why I get this one itself. Okay, so that is how we actually achieve the two matrices that will answer the question. Okay? Any questions? Alright, so part 3 is not as straightforward as it seems, okay, because you are not forming a matrix that is full of elements, okay? There are parts whereby it is zeros, okay? Whereby we make use of our identity matrix. Questions? Alright? Any counter or other kind of matrices that you want to suggest? Okay. If not, then alright, then that's all for this. Okay, then please submit your homework to the front.
I don't understand how I got it. No.